Hello, I am Peter Verhaas, and this presentation is about a product that we are developing in EPAM. It is a centralized access control management that can be used in a cloud environment for applications that use microservices architecture. I could collect many buzzwords like cloud native, serverless, microservices, and so on, and they actually would fit. But it's not only the buzzwords, it's an application and an architecture. Let's see. First of all, I will talk about the application, what it is at all. After that, I will talk about what the demanding need is that makes it necessary to develop this application. I will also talk about the architecture of the application, but we already have something ready. And finally, I will say a few words about the roadmap and the vision. So I will talk about what we have imagined, what we have created, and what we will develop in the future. First of all, let's have a look at what CNSAC, which stands for Cloud Native Serverless Access Control, or rather Advocada, that is a more rememberable name, what it is. It is access control management that helps to develop applications that let the users to do only those things that they are allowed to do. It is a centralized service which seems to be old-fashioned when everything is distributed. But in case of access control, it may be beneficial if there is only one single source of truth in an enterprise that tells who can do what. It is easier to maintain, there is less room for human error, and because of it, it's more secure. Advocada implements the access control as a service. The application does not need to care about the access control too much. It should care a bit because you cannot eliminate all aspects of access control from an application, but not too much. Especially, it does not need to implement the logic of access control and does not need to care about who can do what. Advocada will do that for the application. This functionality is called authorization. Authorize the user to do the actions that they need to perform their job. The work authentication is very similar, and honestly not without reason. If you do not have proper authentication, in other words, if you cannot be sure that the user is really they claim to be, then authorization makes no sense. In spite of that, Advocada does not do anything with authentication. There are well-established production quality authentication services that an enterprise can rely on. Advocada assumes that the application uses one of these and does not try to reinvent the wheel. It focuses on authorization as a service and does only that. Why do we need a central authorization service? First of all, because enterprise applications are not playfields. It is a serious matter and should not be taken lightly. When we talk about business, we have to be sure that no one can fool around. Everyone has to be able to perform their job, but no one should be able to access anything that he or she does not have anything to do with in the first place. It is usually called access based on need to know. At the same time, applications start to move to the cloud. More and more applications are developed using microservice architecture, where a single transaction initiated by a user goes through many different services. These services all have to be protected. The conventional way is to implement access control into all of these applications. It's not only expensive, but it's also maybe error-prone. Changing access control policies should be propagated through all the systems. It may happen that one service knows different access control policies than a different one. When the access control policies are implemented in a central application, there is a single source of truth. What do we have now in enterprises that we have inherited from the age of the monolith? Authentication is already central, and that's great. Well, not always, but that is nothing we want to deal with right now. If it is not central in an enterprise, then they have to implement it using some strategy and some products. But this is not for Advocada. Authorization is both central and distributed. The central authorization, if there is any, is based on role-based access control, and it is not fine-grained. It gives certain people certain roles on the company level, and you can have certain rights to certain application. The rights, what you can do is application level. If you are a developer, then you are eligible to access the development tools. If you are legal, you can work with the contract database. If you are a technical interviewer, you can create interviews, and so on. The finer grade access control, which could manage, for example, which developer can commit to which directory or who is eligible to approve a specific contract, is hardwired into the applications. The source code repository maintains the list of the developers who are developers of the code in that repository. Some source code repository management software define projects, each with many repositories, and you can define the access on the project level. Legal applications and workflow may define that some rules, like the creator of a contract, cannot approve it. It can also say that certain types of contract can only be approved by directors, and so on. These fine-grade access controls fit the needs of the business, but whenever there is any change in the access control structure, the application has to be changed. Because of this, many times the access control structure is simpler than what the business would optimally need, and new versions delivery is delayed because of the whole application need to be released, not only the change in the access control structure. At first, these drawbacks may not seem to be painful, but as the company grows, the work procedures become more and more complex, and the pain increases along with the costs. Either the cost of the software improvement increases with the complexity, or the human cost of operation, because the application shortages are continuously amended by human interventions. Advocada answers these issues using policy-based record-level access control as a service. The policy-based access control service, or ACS short, is centralized. The access control structures, the policies, are maintained in a central location for all the participating application. The policies define who can do what on which resource. The basic logical entities of the service are users, resource types, and actions. The users are the people or technical accounts that want to perform certain actions on the resources. For the access control service, these entities are transparent. It does not know what a user, a resource type, or an action is. All it cares is the relationship between them, using and maintaining data structures that define who can do what. This transparency is the reason why the service does not really deal with individual resources. It works with resource types. The type in this case is a kind of security type. You can say that that's the type of the document. Actually, that is one certain type of the document, the formatting. The document as a resource, example, can have other types like legal document, contract, technical documentation, curriculum vitae for interviewing, and so on. These are already closer to the type that should be used in the access control service. The real access control related type is the security type of the resource. The resource type identifies the policy describing access rules. There can be many resources sharing the same policy. We can say that the resource access type is the abstract approach to access control, and on the service level, the policy implements this approach. The implementation uses further logical entities. The resource type is the policy itself, or the policy ID, so to say. In a policy, we can find actions and authorities. Authorities is a generalization of the entity user. When we query a policy, we want to know if the current user is allowed to perform certain action or not. The policy does not contain this compiled information for each user and for each action. It is a policy that has to be evaluated for the actual policy query. The policy assigns rights to certain users, groups, or roles. These logical entities are authorities. When the policy is queried, then we provide all the authorities that the current user has. The evaluation of the policy needs this information. If the user is a member of a certain group, then this information should be included in the service request. If the user has a certain role, then the information has to be included in the request. The applications know what roles the current user has in relation to the actual resource, as well as the application has to know what groups the user is in. It may use a separate group membership service, or the group membership may be hard-coded into the application. It's up to the application. Group management is not provided by Advocada. There is another thing that Advocada cannot provide as a service. This is the enforcement. The service providing a REST interface has no tools to enforce access control. If the application does not ask for advice, or if it asks for an advice but then just ignores it, then the advocate cannot do anything. The whole access control is separated into two modules. One is implemented as a service, the advocate. The other one is the guard. The guard is part of the application code. It is very simple, but being inside the application realm, it can enforce proper access. Now, one may ask what the advantage is. We have a service, but we still have to implement a guard inside the application itself. Why not implement the whole access control in the application then? The answer is simple. The guard is only part of the access control. The complex part of the application is the advocate that calculates the control. Only the simple enforcement part remains in the application. The guard is stupid and simple. The advocate is complex but powerless. Together, the total cost of ownership for all the application that uses the advocate is lower than developing the full access control logic into each and every application. Let's talk a little bit about the architectural structures. So far, we talked about the policy as an abstract something that controls the access. More concretely, we should imagine the policy as a data structure. For example, a policy can say that the user, warehouse P, that's me, can hold any resource that is named storage _ room _ door. This would be a very simple policy though. It would make me the single person who can hold that door. A more complex policy contains a set of such structures. These are the access control elements. Each access control element contains an authority and a set of actions. An access control element may be permissive or prohibitive. An access control element is taken into account if the authority is listed in the access control advice request, All relevant access control elements are merged together, and finally a user will have the right to perform a certain action, like holding the door, if there is at least one access control element that permits this action and there is no access control element that prohibits it. The business application UI connects to the application as usual, and the first interface it accesses is the guard. The guard sends an advice request to the advocate and gets an advice. Based on this, the guard refuses to serve the client or forwards the request to the business layer, and then the response is ready. It forwards that to the UI. The access control request, which the guard sends to the advocate, should contain the authorities, including the roles that the user has related to the specific resource, the group membership, and the user ID. Roles are not enterprise-wide roles like legal or HR. If a document, which is a resource with controlled access, has a field that names the owner and it is Jane Doe, and the current user is Jane Doe, then the guard application logic will add the role owner to the set of authorities. If the user is member of the admin group based on some group management service, then the authority admin will also be included in the request. The response is calculated and it will contain all the permitted actions. The very first application that uses the access control service is the Access Control Policy Database Management application. This is a browser-based UI and REST service that can be used to create new policies, modify existing policies, delete policies. Essentially, the CRUD-L create, read, update, delete, and list actions are implemented for the policies. Of course, it is not permitted to just anybody to do anything with the access control database. Every policy has a reference to a meta policy that controls the access to the policy itself. The application works, and access control list-based implementation seems powerful and usable. Let's talk a little bit about the project structure of the development and the governance. As we said in the previous slide, the proof of the pudding is eating it. The architecture and the idea is nice and beautiful, but it is worth nothing without implementation. We need to develop it. This is a basic architectural building block, not something that created immediate and direct client value. It does create client value, but not directly. It is more like a research project. Many open source projects are research projects. They are great for development tools. The developers like the new toys. If a new tool is worth, developers will use it. Business is a little bit different. Business needs a bit more. It cannot be a quote-unquote hobby project. In EPAM, we started a project in which juniors are mentored before they get assigned to client projects. In many companies, sometimes even in EPAM, juniors participating in the training develop some dummy programs. Something that is no use and gets deleted and developed again next year. I personally found it very demotivating and decided to use this opportunity to develop something that is low risk and still can deliver value and can be used if created. The project started with 3 junior developers and with me at the start. We also had a program manager for the training. Currently, end of January 2021, there are 8 junior developers, 3 senior developers who mainly mentor juniors. We have project management support, 1 person. There is a project lead architect, that's me, and we have the program manager. We started during the summer of 2020 and we delivered the proof of concept release in the 9th of September. It was followed by a minimal valuable product 1.5 months later, and now we plan to use the service in real life in a commercial application. This application is already budgeted, there is a commercial support, analysis is performed, and we will start the development in a few weeks. We also have a roadmap with a lot of items in the backlog. We created detailed technical documentation, presentations, white papers. The application uses Java 15, which is at this moment the latest Java version, Spring Boot, and MongoDB at the moment. The proof of concept had minimal UI. The Advocate, a guard developed in the policy management application, and hardwired group and role management. Minimum valuable product already implemented an internal group management, ACL types, and minimal inheritance for better usability. Note that group management is part of the policy management application and it is not a service to be used by other applications, although it can be used as such. The management of the groups, creating a new group, adding users group, deleting users from a group, is also controlled by policies. The minimum valuable product also implements negative, or in other words, prohibitive ACLs. On the following 4 slides, I will show some screenshot functionality of the policy management UI. This screen shows the access control listing. The technical implementation of the policies are access control lists. On the left side, there is a menu to list the ACLs. This is where we are now, the ACL types and the users and groups. I would like to emphasize again that the user and group management is not part of the Advocada service. It's part of the management application the same way as it has to be part of any application that uses Advocada. In the list, you can see the ID of the access control, the type of the access control list, and the meta ACL, which is the security type of the ACL, and it controls who can do what with the ACL itself. If you have the right to add an ACL, then the plus sign appears under the table. The list is paginated, and there is a search functionality. This screen shows the ACL types list. The screen structure is the same as for any list in the application. The list contains the ID of the ACL type, the base ACL of the type, and the ACL that controls the access to the type. The access control elements from the base ACL are automatically inherited by every ACL that has this type. It is usually empty. Advocada does not support general ACL inheritance, so when you want to specify a new ACL, then you have to list all the authorities and the actions. The reason for that is a decision. ACL structures are complex in everyday practice where they are implemented. The inheritance makes them one level more complex. Many times it's already difficult to discover why someone has or does not have access to perform a certain action on a certain resource. Making the structure more complex in producing inheritance can be unmanageable. The base ACL is a very limited version of the inheritance, and it serves the purpose to provide general access rules. For example, there are document resources of different types. Some of these document types may need approval, but it should never ever happen that a document is approved by its owner. In that case, the base ACL may contain a prohibitive access control element that says that owner is not allowed to approve, and then this is inherited by all document ACLs, and it is effective even when it is not specified in the individual document type access control list. This screen shows the creation of the editing process of the access control list. When adding a new access control element to an ACL, the user must select an authority. This step is shown on the screen. The editing process provides a drop-down list providing possible values. In this case, the authority can be quote-unquote any, that is a user, a role, or a group. Since the administration of these is not under the realm of the ACL management, there can be any user, role, or group name that the management system does not know. For this reason, the drop-down box is only a convenience and the user can just type in any ID. On this screen, we can see the next step after the selection of the authority. As opposed to the list of the authorities, the list of the actions is definite. The possible actions are defined in the ACL type. This will prevent the creation of an ACL that contains some meaningless action. An ACL without an ACL type could give a permission to someone to approve a door, but the action approval is meaningless in case of a door. And editing mistakes may also lead to a permission to open a door instead of open, just a mistyping. And it may lead to a lot of configuration debugging to realize why someone cannot open a door. ACL types solve this problem, and at the same time it is easier to select an action from a limited drop-down than from a list that contains all the possible actions for all the resources that may be in the management database. Finally, let's talk about a little bit the roadmap and vision. These are extremely important. A product is only new when it is started, a single moment in time. After that, it is legacy or dead. A project that has no roadmap ahead is a dead project. Advocada is a very much live project. We have a lot of tasks and features on the backlog. We plan to introduce a folder structure for the ACLs. It makes possible to give the management of the different ACL areas in the hands of different people. We experiment with ACL inheritance and how to make it usable. We want to see if there is a demand for that at all. When an ACL changes, then the current management UI just changes it. There is no approval flow for it, and we plan to have an application where no single person will be able to approve an ACL change. We also plan to build business-agnostic business services. Business-agnostic business services are general services that aim a certain task in a generalized way that many businesses use. An example is, for example, Jira for project management. There can be many different applications. Developing them as a service with REST interface and providing them as a service can develop a new application based on these services, creating only the client code using JavaScript, CSS, and HTML. Summary. This is going to be the last slide. The product is ready for deployment and the project is alive. It's not open source per se, but it is available from EPAN, and we are very open to give a try to anyone. Any business application can use CNS ACL Advocada. Give it a try, go ahead and develop business agnostic business services. Thank you very much for your attention.